So good evening, everyone. Thank you for coming to the session. My name is Amit Banerjee. I work as a group program manager for Microsoft. I'm responsible for the SQL Server Database Engine and Azure SQL Database Edge. I have my colleague Saurabh here with me.
Hi, good evening, everyone. My name is Saurabh Agarwal. I lead program management for Azure SQL Database Edge. And I'm glad that you guys were able to find time at 4:30 in the evening for a session on IoT and Edge. Thank you.
So if you look at the landscape today, and if you were watching Satya's keynote, the Vision keynote in the morning, you would see that there's a lot of devices that are being provisioned at the edge to do various business functions where data is being generated at a very high pace. So there is obviously an opportunity for any data provider like Microsoft to go provide data services at the edge. And that is what our Azure SQL Database Edge product is all about. So you have the opportunity to take a data object that's produced in an IoT or an edge scenario and apply any kind of aggregation on top of it or any kind of processing on top of it to give you better insights. And why would someone want to do that? That's entirely because of the amount of data that's being produced at the edge. We're not talking about megabytes, gigabytes, we're talking about zettabytes. And if you had to take all of that data and move it to a central server, whether it's sitting in an on-premises data center or if it's sitting in a cloud, that's a lot of data movement to do over LTE or over a network which is intermittent. So you need the ability to not just store and forward, but also to reduce the data size that is actually being produced at the edge. So we introduced a product in build earlier this year called Azure SQL Database Edge. Today we announced public preview for that product. So if you want to sign up for the product, you can actually go to Azure SQL Database Edge homepage. There's a sign-up form, and that we would process that, and we would give your Azure subscription access to the product so that you can deploy it onto your edge devices. While the name says Azure SQL Database Edge, this actually is a database container that runs outside of the cloud. And you will see something which is very new, is the same SQL database engine, but it runs on ARM64. So if you have a device that is as small as this, as you can see here, I actually have an Azure SQL Database Edge container running on it. It's an ARM64 Pi device, and we're not reducing any functionality. If you can do something in Azure SQL Database Managed Instance, and if you take that database backup that's there and you want to restore it on this, as long as you have data storage space, you could do that. So it's the same consistent engine you can take from the cloud, put it in your data center. From your data center, you can put it in your edge, and you can develop your applications once, and you can deploy it in all three targets in a consistent manner. The second thing that we have done is we have actually reduced the footprint because these devices are really small. So the resource footprint is really small and optimized to run in IoT edge kind of scenarios. In the edge, there's a new requirement that we also understood while working with customers and partners, which was basically streaming data sets. Let's take a manufacturing scenario. You've got data that is coming in a stream format, which needs to be processed before you store it in a database. So we actually have the Azure Stream Analytics engine running inside the database edge container. So now you have the ability to process data on the incoming stream and then store the process stream into a database table. And all of this does not have to go into any other place, but can happen inside your container. So data coming in from a manufacturing scenario in your sensors can go into your Azure Stream Analytics job that you've created that's running inside the container. It gets processed and stored inside a database table. Once you've done all of that, you want to extend the scenario. Now you want to apply machine learning. You want to apply some inferencing on top of it. If you have a trained data model that is either trained in a big data cluster sitting in SQL Server 2019, that's a new capability that we announced with SQL Server 2019 GA, or if you're using Azure Machine Learning to train your models, you can take that trained model, convert it to an ONNX format, and deploy that ONNX model into the Azure SQL Database Edge container. It has native inferencing built into it. So not only can you store the data, but you can also run inferencing at the edge with this container. And this is an Azure product, which means it will have integration with other Azure services. So if you already have Azure running in some shape or form, you can actually sign up for Azure IoT Hub. And the Azure IoT Hub has the ability to deploy an Azure IoT Edge onto that Pi device that I showed you. So once you deploy the Azure IoT Edge solution there, or the container there, you can then take a module from the marketplace, and we just made that module live, which is the Azure SQL Database Edge module, and deploy that module onto IoT Edge. So all of these devices, imagine a scenario where you have thousands of these devices running. You can control and manage a set of 1,000 devices sitting in Azure using Azure IoT Hub. So that gives you the ability to have an operator-less environment that actually does all the work for you of deployment, updates, and even sending down configuration parameters from the cloud. So now I'm going to have my colleague Saurabh talk about how we are actually doing the edge deployment from the cloud to the edge.
Thanks, Amit. So the first step is, as Amit was talking about, the first step in the configuration is that you have your edge device, and that edge device is registered or connected to an IoT hub, right? Now, the IoT hub or the edge runtime provides you capabilities around device management, device property management, and all the modules which you want to deploy on the device. And since SQL Database Edge is a module available for deployment through IoT Edge or IoT Hub, it becomes really simple, a single-click deployment across multiple different devices. Now, we'll look into this a bit more when we when we talk about the capabilities which we are bringing to Azure SQL Database Edge. The key things are we are bringing a ML engine right into the product, which allows you to do scoring on the edge. And you can train your models almost anywhere, import it to your edge solutions or SQL DB Edge, and then run in scoring on the edge devices. Right. Now, the scenario which we are talking about here is very simple scenario where you have your IoT hub, you have deployed your SQL DB Edge on the device, and then you have your sensors, which is streaming data to your SQL DB Edge. That stream happens through Edge Hub, and we have an inbuilt streaming engine which reads directly from the Edge Hub and stores the data into the SQL database. Right? So let me quickly show you the deployment of SQL DB Edge from the marketplace to my edge device. Right? So I have my Azure Marketplace open, and I can quickly search for the Azure SQL Database Edge module and click on Create. So we have enabled 3 different flavors for SQL Database Edge, which will be available at preview starting today. The first is a developer edition, which is has all the capabilities and everything. It's a dev-only edition, free of cost. Right? The other 2 are standard and premium editions, which have the same functionality, but they differ in terms of your processing power. So standard is limited to about 4 cores, 32 gigs of memory, while premium is 8 cores and 64 gigs of memory, which it can address. Right? So let's go ahead and I'll go ahead and deploy a standard version of my SQL DB Edge. And the next screen is where it picks up my IoT hub and asks me for the details of the device where SQL DB Edge needs to be deployed. So let me go ahead and pick up a device where I can go and deploy this. And this is the device which I'm picking up, which is the Raspberry Pi, which Amit was showing you a while back. Right? I have other devices also, and we can go ahead and deploy on any of these devices as needed. Right? So let's say I go and select, and it will bring me to a IoT Edge page where I can pick up the, I should click on Create here. My bad. Where we can go and set up the properties for this module. Right? Now, the properties are pretty straightforward. So if I go here and click on configure, apart from the name of the module and the marketplace image and everything else, there are few environment variables which we need to define. And the one which I've highlighted here is the most important, which is basically your SQL Server admin account password. Right? So let me go ahead and give it a password. Right? And then there are some container create options, essentially options around where do you want to place your data files. So SQL supports persistent volume definition, which essentially means that your data files are mapped onto a location on your host rather than within inside the container. Now, what that allows you is, if for some reason your container goes down and comes back up again, you do not lose any data. Right? So that's the container create options. And then you also specify your port mapping as to where or which port on the host SQL will be listening on. Right? And then additionally, there are two other parameters which we have. These are optional parameters. The first one is the location of a SQL package file, which is essentially a SQL DAC file. How many of you guys are familiar with SQL DAC packs or SQL packages? Perfect. So SQL DAC is basically a schema-only representation of a database, right? And we allow you to specify a SQL DAC zip location. And whatever DAC packs are available in that zip file, we will instantiate those at the time of module creation. So effectively, you can take your on-premises database or a cloud database, create a DAC pack out of it, and deploy it on your edge devices. Right? The second parameter is what we call as an ASA job info, which is basically Azure Stream Analytics job. Right? So you can create an Azure Stream Analytics job in the cloud, export that, and run it as part of SQL DB Edge, essentially providing the streaming capabilities for your SQL Database Edge solution. Right? So I'll skip these two for the time being. Let me go ahead and change the port number to some, so that it does not conflict with my existing SQL DB Edge instance on the machine, and save this. That's pretty much it. And when I click on next, and submit, my IoT Edge runtime would pull this configuration details and create my container on the edge device. Right? So going back to my, sorry. Okay. Right, so the second thing which we wanted to talk to you guys about was the ML capabilities which we are introducing in SQL DB Edge. So what we have done is, for the purpose of scoring on the edge, we are shipping an Onyx runtime, Open Neural Network Exchange format runtime with SQL DB Edge. What that means is, you can train your model in a language or toolkit of your choice. It could be Azure, it could be MATLAB, it could be PyTorch, it could be Skagit, it could be Spark ML, anything, right? Convert that into an Onyx format and push that model to SQL DB Edge and run that model and do scoring on the edge, right? And I'll show you a demo of how we are using Azure ML, or Azure Auto ML in this case, to train a model, convert it to Onyx, and deploy it to SQL DB Edge, and be able to do predictions or scoring on the edge itself on this Raspberry Pi device, which we just used. Sorry. Right, so the other thing which we have here is a typical deployment pattern of how a connected IoT deployment would look like, right? So on the left-hand side of the screen, or rather the right-hand side for me, right on the side screen you have the edge deployments, and on the left-hand side you have your cloud deployments. The edge deployments is pretty standard, as you saw in the previous slide, where you have an edge device, SQL DB Edge running on that device through IoT Edge, and then On the left-hand side, you have all your cloud services, right? It could be your Event Hub, it could be Cosmos DB, it could be SQL DW, it could be Azure SQL Database, it could be anything, right? Even Databricks, Azure ML, all of those services. Now, what we are building and what we'll provide is a native data synchronization capability, which allows you to sync data from an edge device all the way to Azure to any of these targets listed there. So you can take SQL data from your edge device and export it to or sync it to Cosmos DB, to SQL DW, Azure Blob Storage, ADLS, any data target of your choice. Now, why would you need to do that? That's a scenario where you would want to do scale analytics for data coming from thousands or multiple different edge devices, and train your models, do your corporate-wide or the entire scale analytics scenario, right? And the best part is that since this is built on a SQL engine, all of your existing BI tools, reporting tools, would work as is. So if you are familiar with Power BI, working with SQL on-premises or SQL in cloud, you can bring those same capabilities down to edge and query data and do reporting on the data from your edge devices. Right. I'll pass it over to Amit to talk about some key use case scenarios which we are seeing with our customers and solving it with our customers.
So thanks, Saurabh. So if you look at the previous slides, you'd find that we're talking about two different scenarios. One is something that's entirely contained at the edge, and the other which is actually working with the cloud in tandem, where you're doing something in the cloud and you're pushing a bunch of the processing to the edge. So let's talk about a scenario where your vehicle is connected, but there's no cloud on top of it. So in this scenario, you actually have a ship, and this is a customer scenario, and we have a video that we'll show towards the end of the session, where you're actually taking data in the vehicle that's being produced through multiple devices, and it is being put into an Azure SQL Database Edge container for doing analytics while the ship is at sea. At that point, you don't really upload data to the cloud. But once the ship comes back and docks at the station, you can upload the data back to the cloud. Now think of the scenario where our customer here is actually doing analysis of large data sets while they're out in the ocean or the sea, and they don't have the ability to push it back to the cloud for analytics, which means that once the ship comes back, or if they need to call back the ship, that's an expensive process because A, you're not processing anything while you're at sea, which means you have to keep storing the data. And once you come back, you actually have to process all of that data set and then upload it. So your time to insights also increases. If you were able to process all of that data while you were actually on the vessel, your processing time would drastically improve. And when you come back, all you have to do is take that data set, connect it back into the cloud, and the processed data set just gets uploaded to the cloud. You could change the scenario where you're uploading it to an intermediate server, and that server then uploads it to the cloud. That's also possible. But the key part, or the key message that I want to drive through is you have a scenario where the same database runs at the edge, the same database runs in a data center, and the same database runs in the cloud. So whether you choose to process at the edge or in the cloud, that's a decision that you're making based on your business needs and not by feature limitation or choices that we're imposing based on the product that you choose. There's another scenario where you can actually upload it directly. So this is where your operational data now, the data that can be sent to the cloud is uploaded directly into the cloud after the ship docks, or you can choose at which point. Like if, let's say you have satellite connectivity, you can upload it to the cloud. And then you can actually take that data. Obviously, you have more than one ship or vessel. All of that data can be aggregated and put into the cloud for further training. So you can actually create a retraining loop where you are constantly improving on your inferencing capabilities and constantly updating your models using the ML flow that Saurabh was talking about earlier in the last slide. So now you create a cycle where it's not a single process where I created a model, pushed it, and then there's no feedback loop for me to improve. So you're actually creating a constant improving cyclical loop where you're able to improve your not just inferencing capabilities, but also your time to insights. Now we'll move to a scenario where there's no cloud at all. There's absolutely nothing, but it's a completely air-gapped solution. So this is an example of the lens manufacturers. How many of you recognize the brand? Quick show of hands here. Yeah. So I also happen to own a lens from this company. Now, Zeiss is in a scenario where they're actually running this in a factory, and that factory does not have the ability to connect to an external world. So the factory walls are basically the world, and everything has to happen within that world, which means that if they want to do some processing with SQL Server, they have to actually deploy SQL Server inside the factory. So you cannot take a SQL Server setup and run it on the manufacturing execution systems that they run. So they actually process the data centrally in a database, which also means that their time to analysis and their time to action also goes down, because they're able to only get insights once the data flows back into the central server. If they have to increase their production capacity, or if they have to do A/B testing of a new production scenario, they're not able to do that till they run through a full set of days worth of data, because that data has to get processed. With Azure SQL Database Edge, they can actually train a model, they can push it into the Edge database, and as the sensors are producing data, they can start getting insights right then and there. So they're getting real-time insights while the data is being generated by the manufacturing systems. And because it's a small container running the same database engine, with minimal code change, they were able to push the database container into the edge using the same schema and the same data set, or part of the data set that was running in their central servers. So their developers are not really writing another application. They're just pushing the processing further downstream, right where the data is being produced. So this actually helps them do better quality control. Their grinders, their polishers now have the ability to take decisions while they're generating data, and the analysis helps them improve their production processes in a more efficient way. They're able to take decisions quicker, which means if something is not running, or if they want to do A/B testing of a new setting, they're able to do that much faster. So let's go look at how this actually works. So I'm going to hand it over to Saurabh again, and he's going to show us how this entire thing actually runs in a small device like a Raspberry Pi or any ARM64. I don't know if we should call it a server or just a device, but basically you've taken your SQL engine that you're used to running on servers. Now you're pushing that processing onto these tiny devices.
Right. Thanks, Amit. So the first thing I want to talk about is the developer experience, where we are building capability within our tools to allow developers to be able to create database schemas, streaming jobs, your ML models, all of that from a single plane. Right? Now, what you see here is a prototype of what we are working on in Visual Studio, where your SQL DB Edge project today has two different options, or two different sub-projects which are enabled. One is a Azure Stream Analytics project, and the other one is a familiar, which some of you might be familiar with, is the SQL Data Tier Application project. Right? Now, what we have done is, while you go and create your database and the schema and everything else, and you also create your corresponding ASA job, when you build the project, it will go and do a validation of your ASA job along with your SQL schema to ensure that whatever you have written or whatever jobs you have created aligns with the schema of the database. Same for your ML models and everything else. Right? This is a work in progress. We'll be able to have this out in the coming months. Right, so that's the simple thing which we are doing in terms of the developer experience, giving developers the ability to do all of this work from a single plane. The second thing, for the purpose of this demo, right? So this demo is built on a iron ore mining process, where the end objective is to identify the amount of impurities present in the iron ore, the final product. And in this case, the impurity is silica. Right? So the final target is to predict the amount of silica present in my iron ore. Right? Now what I'm doing here is, and I'm using Azure Data Studio, within that the notebook capabilities of Azure Data Studio, to use and train my model for analysis or for predicting the percentage of silica in the iron ore. I'll talk about the model development and all that in a bit, and then I'll show you how the data is getting generated, which corresponds to a typical iron ore mining process. Right? So the first things first, I go ahead and import a bunch of libraries which allow me to do my ML processing. And if you notice in this case, I am importing a bunch of Azure ML libraries. So essentially, I'm using Azure machine learning to train a model and deploy it to SQL. Right? Now, the second thing I'm doing here is I'm declaring a workspace for my Azure ML model training. Let me go ahead and do that. OK, perfect. So my model is, or my workspace is all up and ready. This is the third step. And this data set, this test data set is, we are using a data set from Kaggle, which allows me to do some massaging on the data for the purpose of this demo to show how the model was being built, or is being built in this case. So let me go ahead and import this data set from my CSV file. And once the import is complete, I'll show you that this data set has about 23 different attributes, not all of which are usable or are used in the calculation of silica impurities. So let me go ahead and run this. OK. This is just a simple data frame description where you have about 23 different columns in the data set. And there are different levels of min, max, and varying skewness in the data. Let me show you the skewness of 3 different properties, which is basically the iron feed, the silica feed, and the percentage of silica impurity in the test data set. Right, so if you notice, my data set is fairly skewed. If you look at the percentage of silica, the second graph, histogram, you'd notice that the data set is skewed towards the left. Right? And similarly for the other data sets, it has a very long tail. Right? So there's basically a lot of outliers in that data set. So let me go ahead and run a simple command which will remove the skew from this data set. And once the skew is removed, I'll use this data set to now train my ML model. This basically gets rid of all columns or all attributes which are not applicable for silica prediction. So finally, after all of this transformation, I am left with about 14 columns or 14 attributes which has some impact on the silica impurities present in the final product. OK, so that's just the data science part of it, right? Let's talk about the ML model training. So in this case, I'm going to start a model training with 5 iterations. The reason I'm picking 5 iterations is because it's much faster in the demo scenario. But if you really want to get to a good model, you may want to try with different iterations. Like for example, if I go to 10 iterations, I get a fairly decent model when compared to with 5 iterations. Right? Now basically what is happening behind the scene is that Azure AutoML is trying multiple different algorithms to see which algorithm fits best with the test data which you have. Okay? And this is pretty straightforward. So my algorithms I am training, the idea is that my algorithm should have the least normalized mean root square error. that should be as close to 0 as possible, which basically means that my data is linear in relationship, right? So I go ahead and, oh, sorry. Oh, what did I do? Sorry. Oh, my bad. OK. I didn't realize I had a backslash in the first line, in the comments line. So anyways, my Azure ML model is now getting trained, right? So while this model gets trained, let me walk you through a simple data generation code which I wrote, which mimics the iron ore or the mining process. Right? So this is a Azure IoT module, which let me go ahead and connect here. This is basically, is it visible at the back? I hope. Let me just copy this out to a notepad. Oops. So essentially, there are some 14 different values which I am generating from my data set. And this has to do with the amount of water level in the mining process, the airflow in the mining process through different flotation pipes and different flotation devices. And then also the initial iron feed, initial silica feed, and all of those details. Right? Now, this data set gets generated every 3 seconds. I could change it to X number, but for the purpose of this demo, I've kept it to 3 seconds. Right? And this data, so this data gets generated, and it's transformed using my Azure Stream Analytics query and is inserted into a table in my SQL Edge database. So if I go back over here, let me just pull this up. So this is the table where, oops, let me refresh it. Yep, perfect. OK, there you go. So this is the table where all my data is getting inserted to. Now, hopefully, my model should be ready by now. Let's go and check. So it's done with 3 iterations. It's doing the 4th iteration. And you can see that it was in the first iteration, it found a mean square error of 0.22. Then it went down a bit further. And now it has the best, one of the best models so far, which is with 0.15 mean square error. So we'll give it a few more seconds to finish that iteration. The 4th iteration just finished. And you can see that my root mean square error is about 0.12. To be honest, that's still not a great model. We can probably reduce it much further. The best in this data set I have seen is 0.03, which is within 95% of your accuracy, right? So that's a fairly good model. So this last one should take about 25 to 30 seconds to finish, right? Now, once that completes, what I'll do is I'll write this model to a SQL table on my edge device. And I'm using the models table to do that. OK, so the best it has found is 0.1231. Let me go ahead and insert this model into my database. Right. OK, done. So my model was trained in Azure and is now sitting in my SQL DB Edge database on my device. Right. Now, once that is complete, I can use T-SQL. In this case, I'm using a Python script to run the model prediction. But I can use a T-SQL stored proc. I can use an ad hoc query, depending on your choice, to run the predictions. Right? And for the purpose of this demo, I'm taking the last 60 minutes of data from my data set to run the predictions on. So the last 60 minutes of data would mean every 3 seconds I'm generating a data set. That would translate to about 1,800 different data points on which we are running the prediction. So let's go ahead and run that. That's done. I ran the prediction. I was able to import that data into a pandas frame. And let's go and see the output for my predictions. So this is my initial iron feed. So if I go and, let me hide this a bit so that the legend shows up. The blue line is the silica percentage found in my iron ore, or the final product. The green line is my initial silica input, and the red line is my initial iron feed into the process. Right? So 1,800 different data points scoring done in really like a fraction of a second, right? So yeah, that's pretty much the demo I had for you guys. The basic idea again is the deployment is pretty straightforward through Azure IoT. You can train your models anywhere and import it into SQL and then run predictions on the edge. And once you have done your predictions, those results can be fed back to your Azure ML processing to refine your models continuously. So you can run that cyclic loop of using the predictions from the edge back to your Azure ML or your ML library or whatever ML library you are using to retrain your models and deploy it back to edge. Right? So essentially, you are doing scoring on data where the data is getting generated. So with that, let me hand it over to Amit and talk about.
Great, thanks, Saurabh. So if you noticed the tool that Saurabh was using, that's Azure Data Studio. How many of you have actually used Azure Data Studio? Quick show of hands. So the tool that he was using is a multi-platform, runs on Mac, runs on Linux, runs on Windows. And he was using notebooks to connect to Azure SQL Database Edge. And that same tool can connect to a SQL server, the same tool can connect to a Postgres instance, the same tool can connect to Azure SQL Database in the cloud. So essentially, your experience of operating against the database, unless someone actually went and tried to physically find out where you're actually running your queries, whether you're running it at the edge or you're running it in the cloud, you wouldn't be able to discern the difference. Because our goal here is to give you a consistent experience irrespective of where you're running your SQL database. So the similar slide I had at the beginning of the session where I talked about what we're offering in the public preview. This is what I call our roadmap slide. So we will continue to invest in bringing the container footprint down so that it can fit on even smaller devices. We will have not just stream analytics capabilities, we will also have time series capabilities built into the engine. And as you saw, there's Onyx capability. We'll keep enhancing that so you have things like ML flow more tightly integrated where you can do model management from within the database itself. Like you can train your models in the cloud and push them into a database table and let your algorithms be picked based on their efficacy. So you can have better model management from directly within the SQL database. The other thing is, this is just one device. If you had thousands of them, how would you manage them? Today, we're providing you an integration capability with Azure IoT. In the future, you might come in and say that disconnected scenario, I really like that, but I want thousands of those. For those thousands of those, we're also working on an operator-less experience where you'd be able to manage things like a edge module or a edge database running in some location where you don't have any sort of connectivity, but you still need aggregation, inferencing, and relational storage capability. You'd be able to do that at scale. And the last thing is this is the same database engine. This is the same T-SQL surface area. It's a consistent experience. So any tools that you have, any drivers that you have, whether you use a Java driver, whether you use JDBC, whether you use a .NET SQL provider, or you use a Python driver to connect to SQL, all of those will continue to work whether you're running our SQL Database Edge container on x64 or you're running it on ARM64. So you truly have an experience from edge to cloud, and your developers just need to worry about how much compute capacity and how much storage they have. It's more of a infrastructure awareness of how much compute and storage capacity you have at the edge before you deploy your database. If you're able to extend that to a larger edge server, that thing becomes a SQL server running in a data center. You expand that at a hyperscale level, that becomes Azure SQL Database. So your spectrum is essentially spanning edge to cloud, but your developers are just thinking about coding against a single database framework and having a single code base. We use a single code base within Microsoft to develop the database engine. So the database engine that you see on your screens over here is actually the same database engine that runs in the cloud, the same database engine that powers SQL Server. We have figured out that there's a lot of efficiency that you can bring in by having a single code base. And now we're actually giving you a data platform which allows you to create a single code base for your applications so that you don't have to write a bunch of if-else clauses within your code to figure out where your application should go. So now I'll switch over to a video for the scenario that I talked about earlier. So let's look at how our customers are solving their business problems with
unlocking valuable insights from geodata. We do that to ensure that anything that's built or operating on this rapidly changing planet be done in a sustainable and safe way. Our strategic focus is on digitalization, decarbonization, and sustainable development. We needed a scalable solution, and we need to make sure that it was put on a platform we could build upon in the future.
Traditionally at Fugro we would be using SQL Server on-prem as the main solution for collecting data.
The solution was to move our SQL databases to the cloud. We picked Microsoft Azure. We are a C#.NET development group, so our skills translate very easily over to Azure.
After that we started looking at Azure SQL Database Edge. We could actually mirror the data that's stored in the cloud. It was as simple as develop it once and then deploy it anywhere.
So our development capability actually increases because we're now only developing one solution, not two solutions. With our data now coming to cloud, we are also able to embrace the AI and machine learning capabilities. The data that we're collecting from the sensors on the vessel are all coming into IoT Edge, and ultimately that data is ending up in SQL DB Edge and also being streamed up to the cloud in real time. Being able to update remotely is important because bringing vessels back into port is incredibly expensive. Traditionally, it would take 2 weeks to prep that data and for the client to receive it. What we are now able to do is deliver the first draft in 8 minutes.
Working with Microsoft will enable us to develop technology faster and also serve our clients so we can help them to work in a sustainable and safe way.
So once again, thank you very much for coming to the session. Please fill up the session evaluations. It helps us improve our quality of sessions. We are currently in public preview, so if you go to Azure SQL Database Edge homepage, you would be able to sign up for the preview. We've got some power banks here, so if anyone has any questions, please feel free to come up and ask us questions. Every question gets a power bank. Thank you very much and have a good day.